Hello everyone. Today we're looking at 7.5 parts of similar triangles. This section is largely going to review based on what we've been doing for the past couple weeks, as well as some material from last semester. As you may recall, the words altitudes, angle bisectors, and medians. This material follows the exact same way as previous material with regard to similarity and proportions, but let's just look into it. When two triangles are similar, corresponding altitudes, angle bisectors, and medians are going to be proportional to the corresponding sides. So each of these essentially says the same thing, but if two triangles are similar, that's our big thing, they have to be similar, the lengths of corresponding altitudes are proportional to the lengths of the corresponding sides. So proportional triangles we can abbreviate as that, our little similar proportional thing, our triangle, and then our plurality, have corresponding altitudes proportional to the corresponding sides. So if triangle ABC is similar to triangle FGH, then the ratio of AD, the altitude, to FJ, the altitude of the other one, must have the same relationship as, well, this corresponding side of AB to that corresponding side of FG. Angle bisectors are going to have a, no pun intended, similar function. If two triangles are similar, the lengths of corresponding angle bisectors are proportional to the lengths of the corresponding sides. So if the triangles are corresponding, the bisectors are proportional. So in triangle KLM, if it is similar to QRS, then LP, the angle bisector, must be similar to RT, the angle bisector, in the same proportionality that LM is proportional to RS, the corresponding side of that triangle. Medians, well, once more, if two triangles are similar, the lengths of corresponding medians are proportional to the lengths of the corresponding sides. So if ABC is similar to WXY, then CD, our median, to YZ, the other median, must have the same ratio as AB to WX. So essentially, we have the same general idea, just using our altitude, angle bisectors, and medians. So let's take a look at some practice problems. For each one of these, we want to find the value of x. So, number one, we have our 20, we have our 16. These two triangles are similar. We've got our angle similarity. So we can essentially say that the ratio of PM to KM, PM to QY must be equal to the ratio of KM to XY. Plug in what we know, and we have 16 over x is equal to 20 over 15. Run our cross product. We end up with 16 times 15 is equal to 20x. Simplify things out, 240 equals 20x. Divide both sides by 20, 12 equals x. Number two. Looks like we have angle bisectors, in that this angle is being bisected, that angle is being bisected. If we assume that these triangles are similar to each other, we can say that AP, our first angle bisector, to FQ, our second angle bisector, must have the same ratio as AB, a known side, to DF, the other known side. Plug in what we know. Well, we have x over 8 must be equal to 15 over 12. Cross products. 12x equals 8 times 15, or 12x equals 120, or x equals 12. No, not 12, 10. Third one. Looks like we have the case of two medians because we've got our congruent sides. We've got our similar triangles. So our setup for this is going to be the exact same as the others. We have our TP, our first median, to WQ is equal to SR to UV. Plug in what we know. Let's go with purple this time. We have 13.5 to 9 must be equal to, well, if we look back at our figure, we know that our x is right here on SP. We want SR. Well, if these are congruent, this is x and this is x, so SR is equal to 2x. Meanwhile, over at UV, well, we've got 3, which means this is also 3, which means we've got a 6 down here. Cross multiply. 13.5 times 6 is equal to 9 times 2x. We then have 81 is equal to 18x. Divide both sides by 18. X is equal to 4.5. So let's look at a theorem. An angle bisector of a triangle also divides the opposite side of the angle proportionally. This is known as our triangle angle bisector. An angle bisector in a triangle separates the opposite sides into two segments that are proportional to the lengths of the other two sides, such that if we have JM as an angle bisector in JKL, then essentially we have a relationship between KM to LM as we would between KJ and LJ. We actually talked about this before with regard to distances of our J, but that's in the previous section. So, worked problem. Keeping this in mind, I want to find the value of x. So find that x value given that this is an angle bisector. Well, our triangle angle bisector theorem, we set it up such that QT to ST must have the same ratio as QR to SR based on our angle bisector. Plug in what we know. X over 18 minus x, so this part, must be equal to 6 over 14. Use our cross products, simplify, add 6x to both sides, and divide both sides by 20, giving us x is equal to 5.4. Practice-wise, what's that look like? Well, we want to find the value of x. We have our angle bisector set up, which means we're going to have proportionality between this segment and that segment in the same ratio as this segment to that segment. So let's see, we don't have any letters here. We can put them if we wanted to, but as far as the work goes, we've got our 4 to 6 must have the same ratio as x to 13. Cross products give us 52 is equal to 6x. Divide both sides by 6. We end up with 52 over 6, which is equal to x. But 52 over 6 is a bit of a wonky looking fraction. So we can simplify that as 52 over 6 is the same as 26 over 3, which is the same as 8 and 2/3. When possible, stick to fractions, as decimals are oftentimes rounded. Number 5. Well, we got our angle bisector. We've got our 11 and 14. So we're going to have a relationship between this 11 and 14, the same way we will have between this x and this part, which is going to be 20 minus x, because 20 minus x plus x must equal the full length here of 20. So set up our proportionality. 11 to 14 must equal our 20 minus x over x. Cross products. 11x is equal to 14 times our 20 minus x. Distribute that in there. 11x is equal to 280 minus 14x. I'm going to add 14 to both sides, which gives me 25x is equal to 280. Divide both sides by 25. X is equal to 280 over 25, which is a bit of a ugly fraction. So we'll simplify it down a little bit. Divide numerator and denominator by 5. 56 over 5. Or simplifying that down, we could say that's 11 and 1/5 equals x. That, folks, is the conclusion of today's notes. Please attempt the practice in the folder, and let me know if you have any questions.